Number 54. What is the charge on the anion Z in each of the following ionic compounds? So you're given 4 compounds. It looks like Z is the anion. Oh yeah, it says anion. Normally in an ionic compound you put the cation first and the anion last. Now the way you figure out the charge is by looking at the charge on the cations, because in an ionic compound the charge has to balance. So the charges balance. So the amount of positive charge equals the amount of negative charge. And so you can look at the positive charge on all of these, and that will be equal to the negative charge. Now you have to count the number of atoms too while you're doing that. So let's see how this goes. So A, you have B, A, Z. Now the thing about the Z's here is you're not told what these are. If you were, like if you were told this is an oxygen, you could look up on the periodic table and say, well, oxygen's always a -2, but you're not told the identity. So you have to look at the cation to figure out the charge on the anion. Now, barium is in the +2 column. A barium ion is always a +2. So here you have +2, and so it must be balanced by a -2. Now, since there's only one barium, it is +2, and there's only one Z, it must be -2. So the charge here is, we'll just say -2. Okay, let's do B. Now B, you got 2 aluminums and 3 Z's. So the charges have to balance. Aluminum also is a predictable charge. It's in the +3 column. Now the only metals that are unpredictable charge are down here somewhere. Okay, so if you have a metal down there, you kind of got to look up its charge, and for that you'd use figure 3.3. Like copper sometimes is +1 and other times +2, but aluminum is one of those predictable charge metal cations, so it's a +3. But you got 2 of these, so you got each aluminum is +3, but you got to multiply that by 2 to have a total of +6, because each aluminum is +3, but you got 2 of them. And so the total negative charge is going to be -6. Now that -6 is going to be distributed across 3 ions of Z. Okay, so 6, the way you figure out the charge on each Z is you say 6 is equal to 3 times what? And the answer would be -2. So each Z ion must be -2. Okay, we'll draw an arrow there, and the answer is -2 again. All right, next one is C. So you got lithium now. 3 lithiums and 1 Z. Okay, again, the charge is balanced. Lithium is an alkali metal. All of the alkali metals are +1. Okay, lithium is +1. So you got 3 +1s. So 3 times the charge on the lithium. That's a total charge of plus 3. And so the total negative charge is going to be minus 3. And since that's distributed over one atom, we don't have to do this. It's just, I mean, if you wanted to, you could say, you know, it's the one atom times minus 3. So of course it's going to be minus 3 this time. And last one is D is Hg2Z. Hg2Z. So we got to look up Hg2. Where is that? Well, that's mercury. It's down here somewhere. So you got to look at that next periodic table, figure 3.3. There is a couple of mercuries. If you got one mercury, it's a plus 2. But if you got two mercury atoms, it's a combined total of plus 2. Okay? So it's kind of weird. One mercury atom can have a plus 2 charge, but two mercury atoms together can have a plus 2 charge. This is kind of like a, you know, two atoms are connected together and they collectively carry a charge of plus 2. So you see, that's what we got here. We got two atoms of mercury together, and collectively they carry a charge of plus 2. So all together, those guys have a charge of plus 2, and that must be balanced by minus 2, of course. And there's only one Z. Okay, so it has the minus 2 charge. Minus 2.